Now we could start actually going through the materials and the main topic for this week. As a kind of general learning objective, so they kind of follow on the program that we have for the 7 weeks that we have. So what you will learn is that you will read and write spatial data to and from different file formats. So from shape files, from GeoJSON, from KML file, that is Google standard, and so on. You will know how to deal with projections, do different geometric operations and geocoding, reclassification, spatial queries, spatial analysis, and indeed do these kind of interactive maps that can be quite handy in some occasions when showing results to your friends, and especially when you have multidimensional data, so you can actually kind of benefit of having the interactivity in the maps. So why Python for GIS? Why is it good? Well, first of all, it is nice in a way because everything is open source, everything is free, and packages are developing fast. I just during the morning found some post and posted that actually on Twitter. There was some kind of research done on the popularity of different programming languages, and Python at the moment, based on that research, well, they did it kind of on a scientific manner, but it is at the moment the most popular programming language according to this IEEE journal and their research on the topic. So what that means is that the packages are developing fast, there is happening a lot, and they are maintained well, so that is kind of really good. And what is kind of the nice thing and the, well, maybe the bad thing at the same time, so when you compare the Python and the packages for the GIS, so typically what you have is that there are a lot of people, of course, developing different tools and approaches, but what that means is that you have many different libraries that you actually need to use, and that you need to kind of bundle together and learn how they actually interact with each other. So that can be a bit confusing in the beginning, but when you kind of learn to use them, and the GeoPandas package that I mentioned earlier, so that is kind of in the core for many different libraries, so they are typically bundled into GeoPandas, so that's kind of a good starting place, and what we are basically starting to use next week, right after we have learned how to actually create geometries in Python. So kind of, yes, so there are many packages that can be confusing, but the good thing is that they are developing fast because there's a broad community around them. What is kind of the other side is that, for example, if you use ArcGIS and the Python packages, or Python package called ArcPy, so that's of course pretty nice because you have one documentation that you basically read, you have one way of doing things, so it's kind of clear and neat in that sense. But what is basically kind of the downside of that is that, well, you're then always relying on the development processes of Esri and the kind of schedules that they have and so on. So you're more or less tied to one environment, and that might be not something that you want. And the same, well, QGIS is a bit different. It's open source, so there is a lot of developers in there, and actually Quantum GIS uses quite a lot of Python in the background, so it's kind of bundled into the software there. And of course, when thinking of ArcGIS and the Esri products, they tend to be, it's a commercial product, so they tend to be quite expensive. If you learn these things that we will now teach you during the 7 weeks, you can do most of the things. Well, ArcGIS might contain some stuff that are not maybe that easy to do, but I haven't found any kind of tool in ArcGIS that I've used that I couldn't do in Python. So I have totally switched from ArcGIS into Python and so on. Of course, one nice thing when kind of learning the GIS things from the programmable point of view is that you will have much more deeper understanding what is actually happening under the hood. In these kind of click, track and these kind of softwares and with a lot of panels that, okay, this tool does something and you have some options there. So there is quite a lot of actually happening, and typically you can do all sorts of things without even understanding what you are doing. So you can click on different options and buttons, and it can hide a lot of things under the hood. So when you learn and understand the kind of, well, when you build these things from the scratch, so with programming, at least I learned a lot more of what is actually going on and why certain decisions are important, because they then can, for example, change the results quite dramatically. So that's good. Then in the similar things as well, what we mentioned earlier, Python is highly efficient, highly flexible programming language, and so on. What is also nice, well, in terms of using Python for the GIS, is that most of the third-party software, such as ArcGIS, support Python, so they have like a programming interface, and typically that is written for Python. And there are a lot of packages that has also plugins for R and so on, but typically they have for Python some kind of capability of using them. And then of course, when going to kind of even more advanced level, using databases such as PostGIS, so there are really nice packages so available for Python, so that you can use PostGIS directly from Python and do really kind of heavy load calculations of, for example, massive data sets using PostGIS server-side operations and so on. Actually, now when talking about PostGIS, so there is a new development branch in the GeoPandas package that is kind of the package that we will mostly use, and that's kind of nicely written because it starts to be as fast as PostGIS. So you can do huge and pretty impressive things just by using the Python version of the thing. So you don't maybe necessarily need to use even PostGIS if you have some really computationally heavy analysis. Good, but now we have discussed, can you by the way see? Should I make it a bit larger? Yes. So I mentioned that there are many packages, and I have some kind of list in here of typical packages that, for example, I use quite regularly. Some of them are kind of these bit lower level libraries such as GDAL, that is kind of under the hood of many different packages, and Fiona as well. But as you can see from here, there is quite many packages listed already in here, and there are even more, but these are quite typical ones to use. So the GeoPandas one is maybe the one that you will get most familiar with during the course, because many other packages are depending on this one. Today we will use this Shapely package. That is kind of a lower level library, kind of the library that knows how geometric objects are represented in Python. But then there are many different useful packages such as PyProj that is good for doing projections and so on. So this package understands all different kind of coordinate reference system standards basically, and it's nice because it also understands the Esri standard systems and all sorts of things. So it's good. Then there is a Pysol library, which would basically, if we would take another more advanced GIS course, we would get much more or dive much more into this Pysol package, which is related to spatial modeling and so on. But during this course we will kind of focus on learning the basic geocomputational approaches and how to manipulate data and do these kind of basic things using Python. Then there are many different visualization packages. Well, Contextily is something that you will learn probably already next week. So kind of it's a package that allows you to add base maps for your maps using, for example, OpenStreetMap. GeoViews is a kind of interactive framework. It's pretty cool. Let's see if this course at some point might introduce that as well, but it has quite a different approach of doing visualizations, so we have decided not to introduce that. GeoPlot has different kind of plots. Dash is kind of a Python framework for doing web applications and these kind of dashboards using pure Python. So typically if you do, for example, GIS application on the web that actually can do some analysis, so that typically includes that you actually need to know many different programming languages such as JavaScript, use React as a kind of a front-end framework. Then you need to understand typically something from the back-end side dealing with databases, and then you have the actual application that can be written in Python. So there are many different components when building a web application. But Dash is kind of an easy way of handling all that using pure Python. It's not like full-blown, full web framework for doing those kind of applications, but it's quite nice, so you can do many different things with it. OSMNX is a good package to work with OpenStreetMap. How many of you have used OpenStreetMap for some purpose? Yes, that's what I assumed. So quite many of you. So it's an open, well, it's a global data set of our living environment, including streets and buildings and all sorts of things, land use layers and so on. So this OSMNX is quite nice package to actually retrieve data from OpenStreetMap really easily from anywhere in the world and get, for example, services and so on. And then also do some network analysis such as shortest path routing and so on. Then there are other packages such as SciPy Spatial that has some like nearest neighbor things and so on. And there are, well, there is one actually this misses one package, but there is Rasterio, which is a package for raster processing. And then there is this raster stats library as well. I need to add that here, it's not in here. But this, if you're interested in raster processing, so this Rasterio is a package that you could or you should take a look at. The other one is this GDAL package. Good, so as you notice, there is a lot of these, but don't worry, we will kind of gradually go and dive into these ones. We won't be even using all of these, but they are here so that you can actually take a look later if you're interested in using them later when working with spatial data.